Okay. Okay, guys. So we're going to start factoring. Let me give you an idea of what this is all about. So, factoring. You probably remember, say we take a number like 30. Okay? And we can break it down into its prime numbers. So I'm thinking 30, I'm thinking 2 times 15, right? And if we look at this, well, 2 is a prime number, right? Nothing else goes into 2 except 2 and 1, so it's prime. But I still can break down 15, right? Yeah. And 3 is prime and 5 is prime. And usually I just circle those. And that's it. I'm done. So if I wanted to break this down, write it as its prime factorization, it's 2 times 3 times 5. Right? Turns out we can do this with polynomials. If I have something like, and we'll get into all the details. Let's say
you multiply 2 times 3 is 6, and then if you multiply that by 5, oh yeah, never mind.
you get 30.
Another number.
Say I have this polynomial, 2x cubed minus 2x. Well, first I notice that I can factor out a greatest common factor of 2x. So that's 2x. And then the other one is x squared minus 1. Okay. And, right, this times this would equal that. And then I notice that, well, I can't break down 2x any further. But I can break down x squared minus 1. It's a difference of squares. Well, x plus 1 and x minus 1. If I multiply these two, I get that. So it turns out that I've got, this is prime. This is prime and this is prime. So my final answer is 2x times x plus 1 times x minus 1. This is an intro. Don't expect, I don't get it right now. We'll get there. This is the overview. Eventually we'll get there. Today we're just going to practice pulling out a greatest common factor. But this is the general idea. You take something and break it down into its primes. Okay? Any questions? All right. So how do we do this? We're going to start by factoring out a greatest common factor. Okay? So let's find a GCF in a polynomial. Okay. Well, let's see here. Let's do an example where we have 12x squared plus 30x. Go ahead and write that down. 12x squared plus 30x. And I'll tell you what to look for here. First thing we're going to look at is the coefficients. Okay. So we're going to look at the coefficients and find the GCF for that. Or those, I should say, because it could be 2, it could be 3. So here we have 12 and 30. Is 6 the largest one we can take out of 12 and 30? Anything bigger? I can't think of anything bigger, actually. I think you're right. So from these two, I could take out 6. Then we're going to look at the variables. And look for variables that are common to each term. Okay, so we have x squared, that's in the first term, and we have x in the second term. So we have an x term common to both terms. How many can I pull out or divide out of both terms? One, just one of them. I can't take out 2. I would love to take out 2 because I got 2 I can pull from here. But do I have 2 to pull from my second term? So the most I can pull out is an x. So this is my greatest common factor.
So if the 30x were to be 30x squared, you would be able to take out 2x?
Yeah, if I had x squared here and x squared here, I could pull it out of both. Or if I had x squared here and x to the third here, well, I could take out an x squared from both of them, right? It's usually the variable that you have the least of that you could take out from all of them. Okay? Well, let's figure out what's left because that's our other factor. So 6x times what gives me 12x? 6 times what gives me 12?
2.
X times what gives me x squared? X. So I got 2x. I still have a plus sign. And now let's figure out the same thing here. 6 times what gives me 30? 5. Plus 5. How about x? Can I do anything with x? No, because remember, 6x times something over here has to give me that 30x. So there's my two factors. 6x is one factor. 2x plus 5 is my other factor. Okay? And I just factored out a greatest common factor. Any questions? Pretty easy, right? We'll start off not so bad. Let's do a few examples and then we'll get started. Does it? Mr. Contreras talks too much. Okay. Yeah, you're pretty good at it. Isn't that the irony of it all? 24 minus 15x. I'm going to show you another way to do this. We're going to write our answer over here. Okay? So let's factor. Look at each term. 3? What do you guys think? Anything bigger than 3 that comes out of 24 and 15? No, you got to start thinking of Okay, how do I break down this number? Yes, 3 is it. How about variables? Do I have a common variable in each term? It doesn't factor out. Then put your parentheses after you've pulled out numbers and variables. And then let's just divide this number out of each one. So 3 times what gives me 24? 8 minus, yeah, 3 times 5 gives me that. And then x. Yeah. So the way you could check is distribute it back in. We're undistributing, basically. Okay. Any questions? Okay. Let's try this one, number 2. Negative 21x minus 6x squared. 3 again. But let's make it a negative 3. Only because it's common to both. You're pulling out what's common to both. And I could distribute out a negative 3 from both of these. What else can I take away? Do I have a common variable? X. Yeah, just the x, because here I could take out just one x, here I could take out two x's, but from both I can take out just one. Okay, so I took out everything I can. Now let's work backwards. 7. That's a 7 plus, this time it's plus. And if we're not sure, multiply back in. Negative 3x times 2x is negative 6x squared. So voila. Okay. Let's try this one. X cubed y to the 5th minus y to the 4th. Are there, besides the number 1, because 1 could factor out of everything, right? Because I have a 1 here, 1 there. I could always take out a 1. Do you see what coefficients can I pull out besides 1? What coefficients? Numbers. Besides 1, none. So we don't have any numbers there. But, Jesse, why did you say y?
Because we have a 4 and a 5.
Y to the 5 and y to the 4. So how many y's can I take out from both?
4.
Y to the 4th, right? I can take out 5 of them from here, but I can only take out 4 of them from here. So y to the 4th is something I can factor out. That's a GCF. Anything else? That's it. I got x cubed here, but none there. So now let's see what we put back. Let's start with this. Y to the 4th times what gives me x cubed y to the 5th?
X cubed y.
X cubed and y, because if I multiply these together, I get that again. Minus, that's a good one. What do I still have a factor of 1 here because I took out everything. I took out all the y to the 4ths. But remember, here's where that 1 comes in handy. That 1 coefficient that's invisibly there, it's still there here. So I have to multiply y to the 4th times that 1 to get that y to the 4th back. Okay? Any questions? Okay. Number 4. Five, excuse me, a to the 2nd, b to the 2nd, minus 20 a squared b plus 15 ab squared. We can get this one. I think we're good.
You could do A and
Yeah, A's in both, all of them. Well, let's start with all of them. 5, 20, and 15. 5. 5 is the common factor that I can divide out of all of them. Okay, how about A's? 1A, just a single A. You always, if it's in all of the terms, which one has the least? Because that's what you can take out of all of them. I could take out just a single A. How about B's? Can I take out any B's? Yeah, I got a B squared, a B, and a B squared. So B, this one can only give me a single B, and that's the most I could take out. So now it's just a matter of this times whatever gives me each term. AB. Because if I multiply 5AB with AB, I get 5A squared B squared. Then I got a minus of 4A. Because if I multiply 5AB with 4A, I get that. 3, and I do need the B, right? Because 5AB with 3B gives me 15AB squared. So today, this is what we're going to be doing. Any questions? Just factoring out GCFs. So you're going to get problems like this and then rewriting them this way.